Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit GOYAL. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, as we have seen in previous lecture, I have told you that multivibrator is of three types. We have seen three types of multivibrator. The first one was bistable multivibrator. The second one was monostable multivibrator. And the third one was astable multivibrator. Now bistable multivibrator meant that the multivibrator had two stable states, so we need to apply a trigger signal in order to send the multivibrator from the one state to the other. Okay, it will not go from one state to the other by itself. It needed a trigger signal. In monostable, it meant that one of the states was stable and the other state was unstable. So in order to go from stable to unstable state, we needed a trigger signal, and to go from unstable to stable, it will go by itself after a certain time. So the time after which it goes from unstable to stable state was called as the pulse width of monostable multivibrator. Okay, and the last one was astable multivibrator, in which both the states were unstable, so it will keep on oscillating between the two states, and that was called as astable. Now the objective of this lecture is to understand how we can construct multivibrator using BJT. Earlier we had constructed all the multivibrators using op-amp. So we saw the three kind of multivibrator, and the first one was basically Schmitt trigger. Okay, how did we construct bistable multivibrator? It was due by the use of Schmitt trigger. So in this video I will tell you how you can do the same thing by means of BJT. So let us start with the first multivibrator, bistable multivibrator. So bistable means it has two stable state. See, now when we talk about BJT, it has three regions: active, saturation, and cutoff. In these two regions it works as a switch, and in active region it works as an amplifier. So we will make use of BJT in saturation and cutoff region when we are designing a multivibrator. So initially what we assume, initially both BJTs are in active region. If both are in active region, both voltages V01 and V02 are non-zero. See, at V01 I have written Q, and at V02 Q bar. That is the notation of digital system. If one is Q and other is Q bar, so if one is high, other must be low. But in active region, both the voltages will be non-zero. That is called as metastable state. You will learn more about metastable state in digital electronics when you will study about bistable element. Okay, so just now you can understand, when both the inputs are neither high nor low, they are somewhere in between, it is said to be metastable state. Okay, are you getting my point? So initially what I am assuming is I1 is equal to I2. Okay, both the currents are equal in the transistor, due to which V01 will be, if you apply KVL by this path, VCC minus I1 RC. V02 will be VCC minus I2 RC by this. So V01 will be equal to V02. Both voltages will be equal. Both base current will also be equal. Why? Because the voltage output of one transistor works as input of the other. Same way, output of the first transistor works as input of the second one. So if voltages are equal, the currents will be equal. If base current are equal, collector current is also equal, because in active region IC equal to beta IB. Is this clear? So initially both the transistors are in active region. That means the output voltage of both the transistor is neither high nor low, and that is called as the metastable state. What is meant by metastable state actually? If I explain to you in brief, we take a ball hill analogy. Ball hill analogy. Suppose this is a hill. On this hill, what I have done is, I have kept a ball. Now this state is called as metastable because ball will be at the top of hill as long as it is not disturbed. Till we will not disturb the ball, it will keep on staying at the top of the hill. Now as soon as we disturb the ball, it will either go this way or it will go this way based on disturbance. So this is a stable state and this is also a stable state, but this one is your metastable. So what is meant by metastable state? It is an intermediate state and the system will keep in the metastable state as long as we do not apply a disturbance. And when we apply a disturbance, the circuit will get displaced from the metastable state and it will go towards one of the stable state. Is it fine? So metastable is an intermediate state. What you can say, if high voltage is VCC, low voltage is 0, so you can say metastable is somewhere around VCC by 2. That is neither high nor low. It lies midway between low and the high voltage. Okay. So now what we have to do, since both transistors are in active region, none of them is in saturation and cut off. That means we are lying in metastable state, and to transfer the circuit to a stable state, what we have to do? We have to apply a trigger or we have to apply a disturbance. This current is IB2, this current is IB1. Now I'll say, when circuit is disturbed, when circuit is disturbed, let us say, assume IB2 increases. Suppose some noise enters the circuit or we apply certain disturbance, but somehow we are increasing the base current of second transistor. By increase in base current, the collector current will also increase. So IC2 increases, and if the collector current IC2 increases, I2 also increases. Now once I2 increases, what you can say, V02 is VCC minus I2 RC. If I2 increases, V02 reduces. Now as I have told, the output of one transistor acts as the input to the other. So if V02 reduces, the base voltage of first transistor also reduces. If the base voltage reduces, the base current of first transistor reduces. If base current reduces, the collector current also reduces. If IC1 reduces, I1 also reduces. Hence V01, which is VCC minus I1 RC, will increase. Now this process is cyclic, because if V01 increases, it will lead to increase in IB2. Okay. So that means we have reached a complete cycle. So this cycle will continue until V01 is high and V02 is low. That means Q equal to 1 and Q bar equal to 0. Similarly, if we had applied a disturbance at IB1, the reverse process would be happening. That is, if you had applied trigger at IB1, IB1 would have increased and IB2 would have decreased. Now if V01 is high or you say IB1 is low, this transistor is going towards cutoff and the current of second transistor is increasing, so it is going towards saturation. Okay. So Q1 will enter the cutoff region and Q2 will enter the saturation. If we apply reverse noise, that is IB1 increases, then Q1 will go into saturation and Q2 will go into cutoff. Now the thing is, why do we apply a trigger signal? Now see this circuit. If I ask you about this voltage VB1, see there are two sources, V02 and minus VBB. Suppose this is R2. So by potential division, by superposition, we can find out VB1. So by superposition, we basically have two sources. So we can say VB1 is, what is the value of VB1 due to V02? It will be V02 into R2 over R1 plus R2 due to minus VBB into R1 over R1 plus R2. What about VB2? Same way, V01 into R2 over R1 plus R2 minus VBB R1 over R1 plus R2. That is the value of the base voltages, and that is why I was saying if V02 increases or V02 decreases, VB1 will decrease, IB1 will decrease, and once IB1 decreases, the IC1 will reduce, I1 will reduce, and V01, which is VCC minus I1 RC, V02, which is VCC minus I2 RC. So if I1 reduces, V01 will increase. Okay. So in order to start this process, we need a trigger signal. So what you can say that trigger signal is required to start regenerative process of turning on one transistor and turning off another. Okay. And whenever we will change the state, there are two possibilities, Q equal to 1, Q bar equal to 0, and Q equal to 0, Q bar equal to 1. There are two possibilities in a bistable multivibrator, and for both the cases we will need a trigger signal. Okay, because we want to start a regenerative process by which the multivibrator can change the state, and that is precisely the working of bistable multivibrator. That is, it cannot change the state by itself. It will need a trigger signal. So time taken to change the state, is called as transition time. Okay, that is called as your transition time. So that is the working of bistable multivibrator. Here we don't derive anything, we just need to understand the operation. Moving on to the next case, next is called as monostable multi-vibrator. Okay. This capacitance is actually C dash. Here this C dash is called as commutating capacitor. That is the capacitor involved with the turn off process. Now we have to understand, in monostable multivibrator we have one stable state and the other state is unstable. So here when we talk about stable state in monostable multivibrator, what about the stable state? In stable state, Q1, this transistor is Q1, this is Q2. Q1 is actually off and Q2 is on. Okay. Q1 is off and Q2 is on. If Q1 is off, you can say that I1 is 0. If I1 is 0, V01 is VCC. When Q2 is on, V02 is VC saturation, which is approximately 0. So V02 is 0, which is low, and V01 is VCC, which is high. That is the stable state of the circuit, in which state it can stay for as long as it wants. Now if this is the capacitor voltage VC, what is the value of VC then? VC is V01 minus, this voltage is VB2, which is VCC. VB2 is actually VBE saturation. So the capacitor is charged up to VCC minus VBE saturation. Is it fine? So the stable state is when your transistor Q1 is off and Q2 is on, or you can say Q is high and Q bar is low. Now when you want to transfer the circuit from stable to the unstable state, you need to apply a trigger signal. So by applying trigger signal, circuit can be transferred from stable to unstable state. Okay, we can make the circuit go from a stable state to the unstable state by applying a trigger signal. Is it fine? Now what will happen? See, trigger is applied at t equal to 0. At t equal to 0 we are applying the trigger signal. Now when you apply the trigger signal, we will apply the trigger signal such that VB2 becomes less than 0. This voltage, the base voltage of second transistor, we are making less than 0. If base voltage is less than 0, the base current of second transistor reduces, due to which collector current of second transistor reduces and I2 also reduces. Now by KVL V02 is this voltage. It is VCC minus I2 RC. V01 is VCC minus I1 RC. So if I2 reduces, V02, which is VCC minus I2 into RC, will increase. Now this acts as input voltage for Q1. Okay, this is the input voltage for Q1. If V02 increases, the base current of first transistor will increase, its collector current will increase, overall current will also increase, and then you can say V01 was VCC minus I1 RC would decrease. Since current of first transistor is increasing and that of second transistor is reducing, we can say Q2 will go into cutoff. When current of Q2 becomes 0, it goes into cutoff, and current of Q1 becomes high, Q1 goes into saturation. Okay. So Q1 will saturate and Q2 will be cut off. Okay. So that is the entire process of how it will work. But in monostable multivibrator, we know there is a concept of pulse width. What is the meaning of pulse width? That when we apply a trigger signal, the circuit will go from stable to unstable state, but it will come back from unstable to stable by itself. The time taken to come back to the stable state is called as the pulse width of monostable multivibrator. Understand it again. What is the pulse width? The time taken by multivibrator to change from unstable state to the stable state is called as the pulse width. Okay. And that is what I am telling, that by applying trigger signal, we have sent Q2 into cutoff and Q1 into saturation. But earlier Q1 was in cutoff and Q2 was in saturation. So this state will be your unstable state. Now we have to see how our transistor or multivibrator will come back to the stable state. Now when Q1 goes into saturation, what will happen? This capacitor, C capacitor, will start to charge through the resistance R and Q1. This Q1 is now on, so C will charge through R and Q1. So at t equal to 0 plus, C starts charging through R and Q1. Is it fine? It will start charging through R and Q1. Now this capacitor voltage basically acts as the base voltage for Q2, and as soon as this voltage becomes more than knee voltage, Q2 will turn on. Okay. As soon as the voltage exceeds the knee voltage, Q2 will turn on, and when Q2 is on, the circuit will enter the stable state. So that means by applying a trigger signal, we have sent the circuit into unstable state, but capacitor starts to charge, and when it makes the base voltage more than the knee voltage, Q2 will turn on and circuit will again reach the stable state. So we have to find out when this capacitor voltage become more than the knee voltage. So if capacitor is charging, up to what voltage it will try to charge? It will try to charge up to the supply voltage VCC. And what is the initial capacitor voltage? We just now figured out the initial capacitor voltage, VCC minus VBE set. Okay, that was the initial capacitor voltage. Now what I can do is, I can write down the capacitor voltage equation. The capacitor voltage equation is Vc equal to Vc infinity plus Vc0 minus Vc infinity e to the power minus t by Rc. That is VCC minus VBE sat e to the power minus t by Rc. Okay. And one more thing, actually one mistake here. Initially capacitor polarity is like this, but after it charges to the final voltage, the polarity will be like this. So we will say that Vc infinity will be minus VCC. Okay. So it will be plus VCC. Are you getting my point? The capacitor polarity is also reversing. So it will be VCC plus 2 VCC minus VBE sat e to the power minus t by tau. Now how to find out this VB2? You can find out this VB2 by applying KVL like this. Okay. So when we go from minus to plus terminal, we will say plus VCE saturation. Why VCE saturation? Because Q1 is in saturation. So the voltage between collector and emitter is VCE saturation. Then from plus to minus, minus VB, minus VC minus VB equal to 0. So VB is VC saturation minus VC. VC saturation. VC was how much? VCC plus minus VCC plus VCC minus 2 VCC minus VB is at a to the power minus t by tau. That was the value of VC. This will also be minus VCC. Okay. So now if you add VC sat plus VCC minus 2 VCC minus VB sat e to the power minus t by tau. Now this voltage must be equal to V gamma for Q2 to turn on. When you apply base voltage more than the 0.7 volt, then only the transistor can turn on. So take V gamma on the right hand side, VC is at, okay, VC is at, 1 minute, VB is VC is at minus VC. So plus VCC minus V gamma equal to 2 VCC minus VB is at e to the power minus t by tau. Now if you ignore VC sat, you can say VCC minus V gamma is 2 VCC minus VB sat e to the power minus t by tau. So from here you can find out the time tau ln 2 VCC minus VB sat. It is simple calculation by taking log by VCC minus V gamma. Now take 2 common. If we take 2 common, VCC minus VBE sat by 2 या VBE by 2 upon VCC minus V gamma. So it will be tau ln 2 plus tau ln VCC minus VBE by 2 by VCC minus V gamma. Now the second term inside the parenthesis is approximately 1. So this time is approximately tau ln 2, or you can say RC ln 2. That is the pulse width of your monostable multivibrator. The second term will almost become, how much it will become? It will almost become 0. The second term will almost become 0. So it will come out to be RC ln 2. Is it fine? Okay. The last circuit that we have to understand is your astable multivibrator. See, in the circuit of monostable multivibrator, what we had shown is something like this. One capacitor and one capacitor in parallel with resistor. So the circuit was not symmetrical for both the transistor. See here, these capacitors are connected. So circuit is same for both the transistor. Now what will happen? How this circuit will work? This circuit, how it will work? If Q1 initially, suppose Q1 is off and Q2 is on. Okay. If Q1 is off and Q2 is on, then what will happen? C2 charges through R2. Okay. C2 will charge through R2 like this. So as VC2 increases, VC2 also works as the base voltage of first transistor. VB1 increases, due to which IB1 increases. As VB1 becomes greater than knee voltage Q1 turns on and Q2 turns off. Okay, that means the circuit has changed the state. Now when Q1 is on, this C1 will charge through R1. C1 charges through R1. Now voltage of this C1 works as the base voltage of second transistor. So I'll say as VC1 increases, VB2 increases, IB2 increases, and when VB2 is greater than V gamma, Q2 turns on and Q1 turns off. So it will again go back to the initial state. So in this circuit, the circuit will keep on changing the state all by itself. It does not need a trigger signal. So it will be called as the astable multivibrator. So what is the time based on monostable multivibrator definition? We have seen the time taken to change the state is RC/ln2. So in the first case, what is the time taken? The time taken for C2 to charge is R2 C2 ln2. What is the time taken for C1 to charge? R1 C1 ln2. So this will be from state 1 to 2 and this is from state 2 to 1. So what is the total time period? It is the sum of the two time period. So time period is R1 C1 plus R2 C2 ln2. If R1 equal to R2 equal to R and C1 equal to C2 equal to C, the time period will be 2RC ln2. That is 1.386 hours. Okay, that will be the value. Okay, now one thing, if you observe, I have shown a voltage V here. What is this V voltage actually? If you don't connect R1 and R2 to VCC, if you connect them to V, then this C2 will not charge up to VCC, it will charge up to V. If you charge it to a different voltage, this time will change. Okay, so to change charging time, we can change the voltage V. In that case, the time T1 is actually R1 C1 log 1 plus VCC over V, and T2 is R2 C2 log 1 plus VCC over V. Now if you see, if V was connected to VCC, it will be the same thing, R1 C1 ln2 and R2 C2 ln2. So the time period T1 plus T2 is a function of voltage V, and that is why it is called as voltage controlled oscillator. Okay, that is VCO, because by controlling the voltage we can control the time period of oscillation. Okay, so if we summarize what we have learnt, we have covered bistable multivibrator using BJT. It needs a trigger signal to change the state. In this one BJT is always in cutoff and the second BJT is in saturation. Okay, then we studied monostable multivibrator. It needed a trigger signal to go from stable to unstable state, but it comes back to the stable state by itself. Here we derived the pulse width RC ln2. Then we saw astable multivibrator, which keeps on oscillating between the states by itself, and its time period was R1 C1 plus R2 C2 ln2. Okay, so that is the concept of multivibrator construction using BJT, but this topic will not be asked in GATE examination, so only prepare this if you are preparing for ESE. Okay, it is not important from GATE point of view. I hope this is clear, and the only formulas that we need to remember is that of the pulse width and the time period. Nothing more than that is required from this topic. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.